Hello, so I am back. If you remember last time, I left you about this making an enclosure using non-metallic materials. So we started with what was obviously this sort of a thing, saying how do we make a cup. This is sheet metal. I left saying eventually we can replace sheet metal with non-metallic objects, because we have the problem of insulation and problem of cost, problem of weight, problem of sealing and other things. So you see here, while this has been addressed at some level at the sheet metal point of view, and sheet metal always depends on bending on the edges, and then what happens to the corners, how to do and all that. That was the big 3 acrobat files which I have shown you. Now we will come back to how can we make this in plastic. Plastic, I mean generally something which is made using a non-metallic material. In this case, I have my hearing aid case. I have 2 of them in fact, saying one has all these edges which are made to look a little different, and one fully rounded. And then if you see the amount of detailing, because it is an expensive thing, the hearing aid costs a lot of money depending on which part of the thing and whether you have insurance. So extreme care has been taken to make sure that when we open it, it opens clear. I have maximum amount of space. I have space here for keeping the small batteries. So the batteries go here, and then this is how it looks like. Then I have place here for keeping the actual hearing aid. Now this whole thing has been made in a non-metallic material, and for some detailing and semiotics, they are all made to look like this. This is not a replacement for metal. It is just that it carries certain meaning and all that. Why they make these things can also be easily rounded off. However, when you come to a piece like this, it looks fine from the outside, it looks fine, and you have all this corners and all. This is slightly better, corners are better. Only thing is, if you want to actually make something which has fully rounded corners like this, you involve having to make special deep drawing tools. Deep drawing tools are compared to the thickness of the material. To make it like a tube, things cost money. Now I will start with another method by which we try to make these enclosures using the same method as if we would do of working with cardboard or sheet metal. So I have started with a hypothetical case where the one dimension of this box is around 40 millimeters, the other is 120 by 80, more out of convenience than any this thing. So you will notice that it has invariably all the 6 faces which you can think of. So one simple way, like what I have shown you other way, is probably to make, I will call this left side face in the front and the right side face in one sheet of plastic or cardboard. Similarly, take the one at the back, that one at the back, the one at the top at the bottom, and then you have 2 U's, and then you match the U's together. While at one level it is okay, you will notice that bending is still not possible, and you ended up with this. How do you treat the edges? When I started, very conveniently in this drawing, very conveniently I have ignored the thicknesses. You have seen this. 120, 80, 40 is the final object I need. In this case, I have taken the external dimensions, but then if you wanted the internal dimensions, you can also add the thicknesses. Very conveniently, at the point, at that starting point, I tried to avoid this confusion about the thicknesses. Now, when you look at this drawing, one of the first things you will notice is obviously a corner needs some overlapping like this. You understand? Only with this overlapping, things will join like this. And in this case, that small white edge what you see is a highlight that is generated from the, what do you call, the rendering program to make these things visible. It is not an automatic feature of the plastic materials that we use. The next slide will show you, in case you want to make this a load bearing enclosure, you need to probably reinforce the corners. You have seen that the corners are reinforced using small rectangular pieces of material, which will ensure that these two things join together. You have a lot more extra space to join. This is exactly how, in fact, if you look at a injection molded piece, probably the corners are supported. Any injection molded piece, whenever you have two joints, the corners are supported with that. Now you see this. The next slide will show you a little closer view of the same parts. If you see close, every edge ends up with, I think here you see in the bottom corner, very, very interesting detail is hidden here. What is the detail hidden there? Saying those members what you need, if you need to have them touch in the corner, you need to take a decision upfront saying which are the edges which need to be covered fully, which are the edges which don't need to be covered fully, and so on. So, when you come here, you have this beautiful corner here. The next slide will show you the outside will probably continue to be as it is, but for this I have deliberately given a small radius here so that it renders properly, otherwise it will render it as a small thing. Now, having done this, you see here, I will come to a corner here, you will see some very interesting detail here in the corner. The previous slide I was talking to you about, you take a decision of what fits where. In this case, the green representation is for the bottom face with two of these green corners that are joined here. Why do we need these corners? As I have explained to you, need them for the strengthening of the corners, and then subsequently I will come with something. And then one more I was telling you, up front you need to worry, or you need to design the corners. You see here this red piece represents either the front or back cover. In this case, it is the rear or the bottom cover which will go and sit exactly in the corner here, and wherever two of these materials join together, it is possible for us to use some adhesive or the other, and for further strengthening we can probably use some other fastening devices, and which here comes the small, what do you call, surprise. You can probably even make all these reinforcements in the corner using metallic or any other different material. It could be an aluminum tube. An aluminum tube will be much stronger, only disadvantage being that we cannot directly use an adhesive to join it. Now coming back to the type of plastic and things are conventional acrylic, and I have a sample here. See, typically these are all acrylic samples, and I have other samples like this. So if you see all these things, they are all made with different types of acrylic. These things stick well by dissolving them in a solvent. Typically in this case it is the same chloroform which is used to save our lives. See this nicely, I can put one next to each other, and then this is where I would like to say we try to show this, sir. All these joints wherever we want, we just need to introduce a little bit of that solvent here. So what was generally made there, this gap, unless they are done by special laser operations, usually a gap will come. The moment the gap is there, all you need to do is put a little bit of the solvent, hold it in the same position, and then eventually they dissolve well and join. Now is the solvent only solution? No. You can use any other thing. Typically these days people try to use cyanoacrylate. Cyanoacrylate has some limitations. One of them is both the surfaces should be flat and they should wet well. In case both the conditions are not possible, you can even use any other polyester adhesive. You would have seen so many two component polyester adhesives, you can use any of those things. Next slide, as I showed you, this is the detail which is there. Now you see there is a nice thickness of the rear plate. The thickness of the rear plate will exactly sit here. And then it is possible for me to make it practically one piece by joining everything together, and then I have a nice enclosure in which I have the bottom member, I have the rear member, then I have these reinforcements also. This is about as good as a molded enclosure. Only thing is very laborious and depends on skill oriented, and if you are a designer, probably your energy is better spent in designing for other features, whether it is enclosure, whether it is thermal, or whether electronics engineer, or in case you are an instrumentation person, or if you are a chemical engineer, you would like to concentrate on your basic knowledge, not about how to put these things together, because somebody has worried about them. The next slide is going to show you some enhancements we can do in the corner. You see here, oh, this has a beautiful something here. You have seen this. So the mechanical engineering thing, it's called filleting. What this filleting does is, whenever you have two surfaces like this joined, this outside this surface and this surface, or this surface and this surface, you fill up the corner. This is typically used in the case of castings. It is also in the case of welding and so on. Main advantage being you have a tremendous amount of strength and weld that can take place, and this is exactly what is followed in the case of regular injection molded plastic. This is only shown as a matter of saying it is possible to do, but in reality it is not possible to make things like this. In extreme cases where you want to simulate that this has to be passed to a person who is doing the molding, you can probably do it by taking a piece like this, putting it through a milling machine, or what you call through a routing bit, and then try to make a profile and make it sit here, and after all the operations over, remilling it to make sure it looks a little like the original. But the reality is probably more like this. See what is done here is that filleting has not been done. This filleting is difficult to do, and we have a sharp corner here. So we can still make use of the sharp corner, but however those edges which are visible outside, do not have too much of a purpose except getting in the way and do not add to the strength and all that. The filleting in the previous thing was required because this, if you do not fillet it in the mold, there is a good point for a crack to start forming. Crack not by any other thing, whenever some stressing is done, wherever a change of section is there, chances are the crack will start. So imagine there is a force coming on this trying to pull the part apart, then the crack is likely to start here. So in that condition, that filleting is required. But however, in our case, in the normal case, you very rarely do that. So what people do is, they take these long members and using either normal sanding or using an emery or using some other thing, some other manufacturing process, they try to round off these edges. Once it is there, now you join this, now you have a member which is about as strong as you can imagine. Now you see further things can be done. You have seen that. I will draw your attention to this corner. You have seen that the center of this, are a little, they try to follow a little, saying you maintain a same uniform thickness all around. If it were a molded piece, this would have gone a little inside, because this outside thickness and our reinforcement also are available. So this can go a little outside. In fact, the edge of this circular feature can touch this edge here and touch this edge here, and you can make things which are much more can you see material inside. Now you see here, this is only for purposes of illustration, I have shown you these things. Next slide will show you, if you carry out those openings directly to the other side, it almost looks like a regular molded box. That hole can be drilled through. Probably you can hold it properly in a milling machine. The moment you do this, the other extra very nice feature you can notice is, if you put a cover and drill through the whole thing, and then you put the same reinforcement on this edge, you can probably put a screw here and then hold things together. And to get over the problem of this being a soft material, and then it may not be amenable to threads being cut in it, which is called tapping, you can even put a steel insert into it. That steel insert will have threads which are made out of harder material. So we have this object. Now you see here the completed object. Now it's more convenient for us. Intentionally I wanted to show you the corner how this is. You have seen this. If I remember here, in my thing I have not taken sufficient care. So you see here, this seems to be visible here. So get over this problem, probably it is much better to make the whole thing into one what I call homogeneous material, and do this last part of this formation. That is a fabrication process. This is called a counterbore. Try to make the counterbore. So you make all these gussets, you put all these things, and then you put the other reinforcements, make a pilot hole, and after it use a milling cutter, an end mill, to make this nice things here. So we have something which is as good as the original material we have chosen with, and ready. You see here, main thing is you can follow your heart's content, all the designs which you are talking about. Now I will draw your attention to a very common thing. I would like to acknowledge whoever the manufacturer of these items are. Items like this are available off the shelf, and usually some of you would have seen this also. You have seen this very beautiful. I like such things. A bit of wit, a lot of reality. Reality is, if open source software is available, why not have open source hardware? So Beagleboard started with this, saying you buy a Beagleboard and then you have of course so many of them. I do not know all the names, is one of the early things, no? And you see here, fantastic word, the beagle bone. They have played very nicely on the lovable beagle and then a bone with which it plays. In this case, in the case of the open source hardware, they are talking about hardware which is available after the, off the shelf. Then why not the enclosure for it also? Open source. So I'll go back to the beginning and start where it all started. See, when we have enclosures like this available, why not we also start building things to our requirement? And in fact, the very word open source, they have ensured that all the plans are available. But then like you, it's not easy. It's a highly skilled job to get these things working. So you'll see a small difference between that using adhesive for the corners compared to this type of a construction. You've seen this one are plans for trying to make the whole object from a flat condition. So I'd like to show you, we have all these beautiful plates. One thing what you notice is planar, thin planar. Plain, absolutely. Can you see? I mean, you may not be able to see the thickness. That is how planar they are. And this can be, this is probably a 1.2 millimeter sheet. One of the simple ways is trying to make one fit in the other like this. Understood? I have two things here. You can see the offset. I had to put them inside and then I try to bend them, and then if I have a proper end piece will fit here and somehow hold all of them together before they fall apart and make a permanent adhesive. I have a beautiful box. I will say beautiful enclosure with all the limitations of this is only meant for a prototype, for the proving the basic technology. This may or may not be suitable for you for all other things, including the index of protection classes. And then it can be made with any material. You see here I have a beautiful shiny material. This is probably acrylic, but this can be done in normal styrene. You can also do it in polycarbonate. So many other materials are there. Advantage being everything, if designed properly, fits miraculously. Disadvantage being if it's easy to put together, it will come apart as easily unless it's a very space grade component. Now how do you get over this problem? So several methods are there. You see here there is a small detail here in the corner. This all looks okay. This looks okay, this looks okay, this looks okay, except this small detail here. I will try to see if I can go back. Now if you see carefully the small picture which is given by the manufacturers, this is the same thing what I tried to show you, saying one part goes into the other, little bit of an extra projection, except that in this case, while these edges are treated in one way, these two sides are made to fit each other in a different way. So I will show you another of these examples. Please have a look at this. You have seen the small grooves in this. These grooves, those members go inside. The moment they go inside and project outside, that whole thing of it coming apart will not be there anymore. It just will not come apart. And then we also have other detailing here. There are several openings. You seen that, no? Several openings here. And there is another small key, I do not know, and then I do not know if it's broken or actually it is intentional. The actual sample I will try to show you what it is.